Good morning, good afternoon, good evening, whichever is applicable to you. Welcome to pre-lab lecture recording for chemical equilibrium, calculating pH and determination of power capacity over power solution. I'm assuming that you have read the background procedure and even use any other resource such as Chen came to text to understand the basic or introduction to power solution and acid phase theory in general. If you are not taking the lecture right now, I'll recommend that you read any general chem to text on calculating the pH of strong acid, strong base, weak acid, weak base, and power solution. Read on Anderson-Hasselbalch equation. What I'll do is just go through the data sheet real quick, show you the equation which you will need. Allow me to share my screen so that you can look at my whiteboard. All right, right now you should be seeing the whiteboard. I'll be writing the equations, constants if need be, and I'll be toggling between the procedure and the data sheet. If you didn't get the copy of the data sheet, please number or make notes, write somewhere the numbers I do have on the data sheet. I distributed this handout. You should have this so that when I write the equation for, let's say, item number 15 or item number 5, you will relate to that. There are three parts. Part 1, strong acid, strong base phase. Part 2, part 3. And in all this, it's just preparation of a power or different power solution. Let me just start by giving you an overview, some of the skills you need or knowledge you need before you get started. For strong acid and strong base, all right, strong acid, strong base, determination of pH of a strong acid, strong base. How do you determine the pH of a strong acid? I don't want to go back to, you know, what constitutes strong acid, strong base, but pH for a strong acid, all right, is acid, is given by the negative log of hydronium concentration. This is hydronium concentration, H3O positive. For base, POH, not pH, is given by negative log of hydroxide concentration. And of course, if you are asked to find the pH of a base, pH plus POH equals to 14.00. This is an equation you should have learned in the lecture, or it's given introduction in the introduction to acid and bases in the lab manual. Therefore, pH of base is given by what? 14, rearranging that equation, 14.00 minus POH. This is manipulation of equation. Let me number the equation here. Let's say this is equation 1, equation 2, equation 3 here. There will be equations. You don't see it in the background, but you are expected to know. Now, apart from that, molarity, all right, molarity of a solution is given by the number of moles of solute, all right, of volume in liters of solution, volume in liters of solution. Let's call this equation 4, molarity, which we can rearrange this equation, all right? We can rearrange this equation to find the number of moles by multiplying molarity times volume in liters. Let me use subscript L for liters. Therefore, this is equation what? This is equation 5. I'm just giving you equations we will use in completing the data sheet you see there. Now, for solid, all right, number of moles is given by the mass in grams over molar mass over molar mass. You may be given this, or you may be required to use the periodic table, all right? Periodic table to determine the molar mass. But turns out that we are given the molar masses of the solid we are going to work with. This is equation 6. Let me just use this equation 6. All right, equation 6. For weak acid, all right, let's label these weak acids and weak base. A weak acid, does not dissociate completely, just slightly ionized, about 5%. And to determine the pH of a weak acid is different approach from the determination of the pH of a strong acid. Hydronium concentration, all right? Hydronium concentration for a weak acid is given by the square root of Ka times the concentration of weak acid. This is just here. I'm using here, this is generic what? Generic formula for weak acid. You need to find the concentration of which here. Concentration, you have to use the equation mass, or rather number of moles, not mass, number of moles. This is given by number of moles over volume in liters. This will give you what you will plug in there. Ka is given. Ka, this is acid dissociation constant. At times you may not be given this, you may not have the acid dissociation constant, but you can rearrange the equation if given pKa, Ka, all right, where Ka equals 10 raised to negative pKa. So you need to know that you are given the pKa values for the acids we will be working with, and we need to rearrange to get the Ka value so that we plug it in this equation to get the hydronium concentration for weak acid. For a weak base, all right, weak pace here, okay, we will have weak pace, we will have weak pace, hydroxide concentration. All right, hydroxide concentration is given by the square root of Kb times concentration of this is a weak pace. Let's just have that as a weak pace. Therefore, pH or POH is given by negative log of hydroxide concentration, negative log of hydroxide concentration. This implies pH of a weak pace is given by 14.00 minus POH. So the point here is, if you look at, if you are dealing with a weak pace, which we will have to do it in this lab, is look at the relationship between pH and POH, pH and POH. It turns out that the pH plus POH equals to 14. So you need to find the POH first, all right? You need to find the POH first and the negative log of that. The concentration given here, I don't want you to think that the concentration negative log of that, this is given by the number of moles of volume in liters, or whatever you will be weighing, or you will weigh, find the mass, all right? Know the volume, divided by that. It's gonna give you the concentration. Kp, we will have to find that. If not given, you will plug in this equation. Ka times Kp equals to 14.00, which means Kb, all right, Kb is given by not 14, but 1 point, I meant to say 1.00 times 10 raised to negative 14, which is Kw. This is Kw, which means Kw over Ka gives you Kb at 25 degrees Celsius. 1.00 times 10 raised to negative 14 over Ka Kb. This equation here you will need in order to find the Kp, because if you look at the handout, all right, we are not given the Ka value, I mean Kp value. You'll have to relate Kp with Ka using this equation, all right? With that, of course, you know the concentration of hydroxide, you'll have to determine that from the given mass. Without wasting my time with those equations, hopefully you are making your own notes. Let's get started with part one. If you read the instruction, you should be able to come up with the conclusion that what is the total volume of the solution. For example, in part one here, strong acid, strong base, all right? Strong acid, strong base solution. You are required to determine the pH number 2 here, all right? For number 2 on the data sheet. This is pH of a strong acid, all right? pH of a strong acid. We'll use this equation, pH equals to negative log of hydronium concentration. And from the instruction, look at what you have by the end, all right? If I look at this statement here on part one, you should have now 50 ml of 0.1 strong acid. So volume, all right, volume in liters should be 0.050 liters. And the concentration, all right, concentration or molarity is 0.010. Do not use the 0.1 you if you recorded the 0.1, that was from the stockpile, from the fume hood, but now when you perform the experiment measuring 25 ml of deionized water, the acid 0.1, this is the final volume of the strong acid in part 1. These 1, 2, and 3, you are supposed to use the pH meter, but here, number 2, the pH over strong, so this is going to be pH. Therefore, our pH equals to negative log of 0.01. 0.01. That's what you need to remember for number 2. pH of 0.01. This is the value you need for that. For number strong base, all right. Number 4, all right. This is the pH of strong base. pH of a strong base. You realize that in this case you are dealing with the base NaOH, just the way you did in for the strong acid. You'll end up with what? You'll have 50 ml. Prepare 50 ml of 0.01 because it's 0.0100 and 3 significant figures. First of all, POH, all right, is given by negative log of hydroxide concentration, which means negative log of what? 0.0100, not the 0. What? Not the 0.1, all right? That was a concentrated paste, but you had to dilute. Therefore, by making 50 ml, the concentration changed from 0.1 to 0.01. So once you have this will give you pOH. Therefore, pH is given by 14.00 minus pOH. This is what you will have to do for number 4. You see number 4, you have to have number 4 for strong base. And after mixing, of course, for 6, theoretically, should take place. We expect this, but I guess there was some issues with the deionized water. For some reason, it was basic pH of more than 7. And you realize that maybe after mixing number 5 here the pH meter didn't read 7, but theoretically this should be pH for neutralization 7.0. 3 significant figures. So theoretically for number number 6. Now for tonic acid, all right, let's title this as phthalic acid PAVA acid PAVA. which is what? KHP. This is just the KHP. There, I believe there was another equation I will have to show you when I shared my, I don't know if I have, yeah, this one right here. We will also be looking at this. All right. We will need this for KA, KB. Now, let's see, number 7, you are supposed to read the instruction on how much you need to weigh out, all right? You need to weigh out in order to I'm looking for not that, but the instruction. I'm looking for instruction, not this some other document, but I wanted to make sure that we have the information we need to, all right, we need in order to do what? In order to know how much of what should be measured. All right, it is from the instruction. Let's see, I emailed myself the instruction, note that it is given in so for phthalic acid, you need to read the instruction on how to determine the pH of a weak acid. Now, before we get to 8, all right, before we do the calculation for number 8, I will just go to 9, all right, 9, you have to read the manual and see how much you have in there, all right? Grams of, if I look at the grams of, allow me to real quick look at the grams of phthalic acid. If you didn't read that, grams of phthalic acid, all right, the grams of phthalic acid, KHP, grams, or rather mass, all right, here mass, just wanted to say mass is 0.82 grams of KHP. You need to record exact, all right? Whatever you had for number 9 from the lab or from the analytical balance, whichever balance you use to record the mass of phthalic acid. Now, number of moles for 10 here, 10, number of moles of KHP is given by mass of KHP over molar mass over molar mass. This is from the manual. It is given. You don't need to use the periodic table. You don't need to use the periodic table. That will give you the number of moles of phthalic acid, which is KHP. Molarity, which is number 11. How do you proceed with molarity? Molarity of KHP, M is given by number of moles, all right? Number of moles of volume in liters. So if we know the number of moles from number 10, if we know the number of moles from number 10, we plug it in this equation to get number 11. Number 11, all right, molarity, we need to know the number of moles. This is from line what? This is from line 10. So here, this is from 10. Number 10, okay. The instruction here is you have to dissolve in 40 ml of deionized water. So here, 40 ml of DI water. Let's see. If you are to dissolve in DI water, okay, it may take a while to dissolve. All right, so that's what you have to put in there with the electrode. I just want to make sure that we didn't add anything. It will take, so this is the molarity of phthalic acid. So the volume in liters is 0.040. I just want to make sure that we know the volume of phthalic acid. I'm getting this value here from the background. If you look at part 2, preparing the phthalic acid. So now this will give you the molarity of the KHP, molarity of KHP. So if I know molarity produced for acid solution, volume of phthalic solution used to make power volume. All right. The volume used to make the phthalic acid, all right, is 20 volume of phthalic acid used to make the power is 20 ml. We're gonna read that volume of acid used. So number 12 here from the instruction. All right, we need to know how many the volume or volume of phthalic acid used. This should be 20 ml because you will convert the volume of molarity, volume of. So here, the volume used right here. So volume used for phthalic acid, you use 40.00 ml volume of phthalic acid, molarity of phthalic acid. So how much? We dissolve in 40 ml, that is the volume of acid. Now, volume of or molarity of NaOH used to make this is number what here, molarity number 13, molarity of NaOH used 0. What? 0.100 molar NaOH. This is the molarity of NaOH use. I'm answering question number 13 here by looking at the procedure. This is of the fume hood. volume of NaOH used, 14 you use 20.00 ml as the volume. You have to do that. The reason why we use this is we want to convert a half. So most of NaOH, I forget to label that, but I'm just going to say number of moles right here. I forgot to label here under 14, number of moles of NaOH used to make powder like that. To make the powder is given by molarity of NaOH times volume in liters of NaOH. You need to change the volume to liters. So this is the equation you will use to answer the question on the number of moles, So for this item here, the number of moles of NaOH used to make the molarity of NaOH, which is given 0.1, yeah, 0.0 what, 0.100, all right, and the volume in liters is 0.020 L. This will give you the number of moles of NaOH used. With that, before we move on to 16 and 17, we need to calculate the pH of course, you have to use the pH meter for number 7, but for number 8, you are dealing with a weak acid, right? This is a weak acid. How do I know it's a weak acid? You are given the Ka value. You are given the Ka value. I think the reason why we were given Ka value here, you see this, there is the Ka value for salicylic acid, KHP, and this is the pKa from pKa right here, number 8. For number 8, pH of KHP solution, this is a weak acid. Therefore, we need to find hydronium concentration first, times concentration of KHP, that is molarity of KHP, where Ka equals to 10 raised to negative pKa value. You are given the pKa value here. This is the pKa value. This will give you Ka. And then the molarity for KHP, we already determined that here. This is the molarity, line 11. C, right? Wanted to say C, line 11. At this point, you have the hydronium concentration for KHP solution. Therefore, pH is given by the negative log of hydronium concentration. You have to remember that first of all, it's a weak acid, and we need to find the Ka from the pKa value given, here. We are given the pKa value, 10 raised to negative pKa value gives you the Ka and then you plug it in the equation for the pOH. That is number 8. For number 7, you had to use the pH meter. So far, we have answered 9 all the way to 10. Here, the 15 and 16, all right, concentration of the acid concentration of the base. For number 15, concentration of the acid is given by number of moles over volume in liters. At this point, the total volume, all right, total volume is 60 ml, which is equals to 0.00060 liters. You started with 40 ml of the phthalic acid, and you added 20 ml of strong base NaOH. And what that means, the neutralization will not take place, but the initial number of moles of the weak acid, which is the phthalic or the KHP, will be converted to the conjugate phase. So number of moles of acid is given by a half times line what times line 10. Line 10. So this is how you find this value here. All right. This is how you find the number of moles. Maybe I will place this. If you look at number 15, the concentration of the acid, that means in the powder solution now, you have mixed weak acid with strong base. It's going to convert half the number of moles. Total volume at this point is 0.060 liters. And the number of moles of the acid is not the original, but a half of the number of moles you had in line 10, This is line 10, you see here, half of line 10 give you, and then it will give you the number of moles, And with that, you have the number of moles, the molarity for the acid. For number 16, all right, number 16, what we'll do is, this is the concentration of the base, which is basically conjugate base, like that. Conjugate base, number 16 here, conjugate base, which is basically number of moles over volume in liters, and at this point, 0.060 liters. So 20 plus what? 20 plus 40. Number of moles is equals to number of moles of what? Number of moles of NaOH, which is in line 1. This is line, C line, I meant to say line what? Right here, number of moles of NaOH. I didn't number that. All right, so ignore this, but the number of moles of NaOH here is what you will have here, which I explained earlier on how to find the number of moles, which is basically 0.020, all right, liters times molarity, which is 0.10. This will give you the number of moles. That's the concentration of NaOH, and the volume in liters. And with this you have now concentration of the acid, concentration of the base in a Pava solution. This is at this point we have Pava solution. Take note of the volume change here. All right, molarity of the conjugate base. So with that, we use now Anderson-Hasselbalch equation to find line 18. Of course, line 17, you had to use the pH meter, but 18, all right, for line 18, how will you use that? We use Anderson-Hasselbalch equation, pH equals to pKa plus log of, I will use lines here. Let me see, the base here is line 16, all right? Line 16 over line 15. This is conjugate acid base pair, all right? pKa here, it is given, or we are given here, pKa is 5.28, 5.28. This will give you the pH over Pava solution, pH over Pava solution. I assume you use the pH meter to find the what, determine the pH of your Pava solution of phthalic acid, That marks the end of Pava solution for phthalic acid. For acetic acid Pava, number 19. All right, for number 19 here, let's see, 19. All right. You need to read the instruction, prepare the Pava solution using 0.1. You use 0.1 acetic acid, 0.100 molar acetic acid. You should be reading the instructions so that you know what to do. Before we get to that, I don't think we even need to do this. We don't need this because already you have to use the pH meter for 19. We'll come back to the pH of acetic acid. It is 20 here. Acetic acid, you need to know acetic acid is a weak acid. All right. You use molarity of this is 0.100 molar. And by the way, acetic acid is CH3, COOH. This is acetic acid. Volume uses 40.0 ml. But we care less about the volume now. Since we know the molarity, all right, this is the molarity. We find the hydronium concentration for a weak acid is the square root of Ka times 0 or concentration of acetic acid, which is this one right here. But, or rather where Ka is given by 10 raised to negative pKa value, and you are given the pKa value here for acetic acid. This is acetic acid right here. Negative 4.792, and please follow the significant figures, rules for significant figures when dealing with assets. Doesn't work the way you handle in regular addition and subtraction. Now let's see. So here you'll have the Ka, plug it in this equation to get the hydronium concentration. So therefore, pH is given by negative log of hydronium concentration. This is how you determine what? You determine the pH of your acetic acid solution. This is number 20. So you need to manipulate, you need to understand that this is a weak acid and there is no way you'll just take the negative log. This negative log of concentration, hydronium concentration, this is for strong acid. This is a weak acid. You have to find hydronium concentration given Ka. If you are not given Ka, you need to use this equation to find the Ka. Then take the negative log of that. You have the K, the pH of your acetic acid solution. So number 21 here, molarity of molarity 21, molarity of acetic acid (0.100 mole). You are given the acetic acid. Volume of volume used here is 40, so 22. You use 40.00 ml or 40.0 ml. That's what the direction states. And then the number of moles of acetic acid before mixing. Number 23. Is it 23 here? Yeah, 23. Number of moles, 23. Number 3 here. Number of moles acetic acid is given by molarity times volume in liters. Molarity right here, 0.100 moles per liter, and volume here 0.040 liters. This is what you use in preparing the PAV, number of moles before mixing. From the instruction, look at the molarity, number 24, all right, 24. Molarity of NaOH. Molarity of NaOH used is 0.100 molar. That's the molarity of NaOH, molarity. You can read this from the background. You need to read the procedure, the step on molarity. What was the concentration of molarity, and then volume use? You can state that 25 volume of NaOH. Volume NaOH used you got to change to liters because we find the number of moles here. We know the molarity, the volume, number of moles, number 26. Number 26 here. All right. Number of moles is given by molarity and volume in liters. Volume in liters right here. Let's see. Volume in liters. Molarity is line 24. This is line 24. Volume in liters. All right. Volume in liters. We use 0.02 liters. This is the volume of NaOH used. Change to liters, 0.020. This will give you number 26 or line 26 from my numbering here, number of moles of NaOH, number of moles of NaOH. Now, we know, I've shown you how to calculate the pH of acetic acid. Line 27, all right, 27 here, line 27. Remember, the initial number of moles, or rather concentration of the acid, number of moles over volume in what? Or rather here, you can say total volume. Total volume in liters. So here, this is given by a half number of moles, or rather line what? Line, whatever you will have in line number of moles of acid, which is line 23, over 0.060. Remember, this one is 1/2, not really, this is 1/2. A half of what you started in line 27, whatever you started in line number 23 here will be 1/2. Why are we saying 1/2? Because when you added NaOH into the solution of acetic acid, half of the initial number of moles will be converted into the conjugate phase. Therefore, half of the number of moles in line 23 will remain, which will be the number of moles of the acid. This is the number of moles of the acid. This will give you concentration of the acid. Concentration of the acid, which is the molarity. For line 28 here, concentration of the base is given by the number of moles of conjugate phase of total volume. This is the total volume at this point is 0.06 liters. And here, the top part, this is same as number of moles of NaOH, which is the same as line what? Line 26. This is C line 26. Say line 26 for the number of moles. For the number of moles, same number of moles, same as, I should have say same as number of moles. And please be setting your equation when you do this calculation, I don't want just to see numerical values without calculation. That leads us to 29 and 30. 29, you have to use the pH meter number 30. All right, number 30 here. pH of power solution is given by pKa plus log of concentration of the base over concentration of the acid, which is in this case for acetic acid. You see acetic acid here, pKa is 4.97, so this is going to be 4.792 plus log of line what? Concentration of the base. This is line, I'm looking at this, line 28, I believe. Yes, line 28 over line 27, whatever you'll have for 27. And that should give you the pH of acetic acid power solution you prepared in part 2, all right? In part 2 of the 2-power solution, lastly now is preparation of the power. This is the second power from hydrolysis of the salt phosphate power solution. This is where you had to weigh out two solids. One of them is the conjugate base, one of them is the conjugate acid. Let's label it first here so that you relate. If we have this, this is Na, and then H2CO4. This is conjugate what? Conjugate acid. And Na2 HeO4. This is conjugate base. Now, from the instruction, you need to have recorded, I'm just going to pick the theoretical file with the mass of each one of them, all right? Dihydrogen, this was 0.4, I think 0.4. Read the instruction, you have to weigh out 0.46 grams. Record exactly what you had measured out or massed out. And this one you had to mass out, by the way, molar mass of this. This is molar mass. One 137.9999 grams per mole. And dihydrogen, I'm looking at the lab manual. The other one is 268.07. So this is 268.07 grams per mole. This is the molar mass. And then you have to mass out. That is what you have to weigh. All right, 0.89 grams. This is what you have to weigh. We need this information Beforehand, it is in the background. I had to read from the lab manual. Now, the pH. Now, calculate the pH of PAVA solution. Let's start with number 32 here. Number 32. How do you proceed with the number 32? First of all, is it an acid or is it a base? If I look at how I label out, that is the acid. It got an extra hydrogen. The other one is a base less one hydrogen. So if it is an acid, you find the molarity. Molarity first is given by the number of moles over volume in liters. You are to dissolve, all right? Dissolve in 50 ml of deionized water. So this will be 0.050. You have to dissolve in, this is what I'm saying, volume in liters. So dissolve in what? Dissolve in 50 ml of deionized water completely. Number of moles, where, look here, where number of moles is given by the mass in grams of molar mass. Molar mass, all right, molar mass, this is what we were given. This is the molar mass of the acid. You had to weigh suggested 0.46. I don't want to see 0.46, the one given in the background. There is no way you will get exactly 0.46 or 0.89, no way. And by the way, the analytical balance or the milligram balance we have in the lab read to 3 places of decimal. So I don't want 2 places of decimal. So having said that, you plug in the equation to get the molarity of the acid. This is molarity of the acid. Molarity of acid, like that. Molarity of the acid. We haven't calculated pH then. So hydronium concentration is given by Ka times concentration of the acid. Once you figure it out, the molarity, you'll plug it in there. Acid. Where Ka is given by 10 raised to negative pKa. And pKa, we are going to use 7. This is rather, this one is 7.9, no, 198. 198. And you get yourself the Ka value. Therefore, pH equals to negative log of hydronium concentration. Because it is an acid, we will have to take the negative log of hydronium. Take the negative log of hydronium to find the pH. This will give you the numerical value for 32. That's what I was doing, number 32. You have to follow this. You can replay again and again to determine the pH of, or calculated pH of the solution. Now for number 34, it's getting more challenging to some of you. Number 34, here. pH of what? pH of conjugate or just with pH of the base. So how do we determine the base? We don't have pKb here, but we have the Ka here. So how do we determine line 34? There is the pH. There is in the background, right? You have to read this carefully, read this section carefully on how you go about it. First of all, you need to know that Ka or Ka times Kb equals Kw. So Kb equals to K over Ka is a base. So that's why we have to find Kb, which is equals to 1.00 times 10 raised to negative 14 over 10 raised to negative 7.198. I think that's what we had before. This will give you the pK, this will give you the Kb. Since it's a base, hydroxide concentration, since it's a base measurement, hydroxide concentration is given by the square root of Kb times concentration of conjugate what? Base. How do we get the concentration? Concentration of is given by the number of moles of volume in liters. Number of moles. Mass in grams, the mass in grams we recorded in the lab manual in your data sheet over volume in liters, which is you had to dissolve in 50. This was around 0.89. Over molar mass, sorry. This one is over molar what? Over molar mass, molar. And I think the molar mass was 268.07. And volume in liters is 0.050. This will give you the concentration of the conjugate base, which you will use here, concentration, and then Kb is from here. Once you have that, all right, therefore, POH equals to negative log of hydroxide concentration. Hydroxide concentration. For pH, you see this number 34, pH over base, pH, right, is given by 14.00 minus pOH. Remember, pH equals to, pH plus pOH equals to 14.00. And that will give you for line 34 here, line 34. So remember to retrace back on how we started, how to find the pH of the conjugate base. From this information here, All right, for the conjugate base, you must change the Ka into Kb, which is what we did here. All right, and then we find the POH, which is what we did here. And then we subtract from 14. They expect you to remember all these concepts from the lecture. And of course, here it's pretty straightforward. I mean, the mass of each one of them you had to record. You had to record for that. Moles, you have to use the molar mass, all right? Mass of each one of them. This is from the lab manual. 35, 36, maybe for those who are writing down 36 here. See lab manual, no, yes. Actual data. What I mean by this is whatever you recorded. 37, all right. 35 and 36. 35. It's the same thing. You have to record exact masses of what you recorded here. And here, exact mass of each one of them. It was suggested as 0.0. Remember which one is the base from here. All right, from here, you know what the base was. Whatever you had recorded here, conjugate, base conjugate, this is conjugate. And remember to record exact, even though it is suggested 0.46, 0.89, you need to record the actual here and here. Now, moles, number 37, all right? Number 37 here, number 37. Number of moles is given by mass in grams of molar mass. And the molar mass for number 37 is what? It is an acid species. So acid species, how do you know acid species? This is the acid species for acid species, conjugate acid. 137.99. So 137.99, 137.99, 137.99. See the lab manual. 38, number of moles. This is acid base. It's mass, whatever you have for over molar mass. Is what you did. Find the number of moles. Remember before mixing, number 39, molarity of, is it number 39? Before mixing, these are pH. Mass 35, 36, did I get that? Was it 35? Number 30, hold on. Number 30, what? 37, you have to measure. Sorry about that. This was 30. Let's pack up this. This is 35. You measured that 35. You got to measure 35. Sorry about that, 35. Mass of each one of them, 36. Moles, 37 moles. So if you look at the moles of this and that, you need to look at that. Now, 39, molarity. Okay, molarity of the acid, molarity of the acid, number of moles over volume in liters before mixing. And here, this is 0.050 L. 40 molarity of the number of what moles over volume in liters, which is 0.050 liters. It's gonna give you that. Molarity of protonated acid, protonated base, conjugate base species in power solution. Now, number 420 here, it's gonna change a little bit because there is no, all right, here, molarity or the measured pH. You see here, this is molarity of protonated weak acid, molarity of the conjugate base in a power solution. Do not forget the change in molarity due to dilution. So number 41 here, 41. This is how we read. This is for acid, not the pH. This is for acid. So the molarity in the power solution, remember in the power solution is number of moles of acid over total volume, which in this case 100 ml. When you mix the two, 50 plus 50. So let's see, not the 50, how this was prepared is while dissolve 50 ml of Swilder solution. So while the first part of power solution, the second part of so you will need to prepare. So once both solution of dissolved, use the pH meter measure the solution. As you did before, you want to create 60 ml of power from these two solutions. Measure 30 ml of each solution, the pH. All right. So this will be number of moles of the acid over total volume here, all right? Total volume is 60. 60 ml because you took what? You took 30 ml of from the instruction you had to prepare a solution, a power solution of 60 ml. Let's measure 30 ml of and mix it. So how do you get the number of moles? All right. The number of moles. Once you have the molarity of acid solution and molarity of base solution on mixing, this will form a power solution. So we will use this to calculate the, you only mix 30 of each. So the 60 ml here is because of the 30, but the question is, what is the moles of the acid, moles of. So if you number of moles of acid is given by volume in liters times molarity. You took 30 ml, which is 0.030 liters. You use 30 ml, and the molarity, all right? The molarity you had to find from line what? Molarity of the acid right here. I think I went far. Right here. Molarity of before mixing. Line 39. This is line 39. Molarity. This will give you the number of moles which will go here. So I need to find the number of moles used to prepare the Pavlov solution. We need to find the number of moles of acid. To get number 41 here. The same thing for 42. Molarity of conjugate this is given by the number of moles of this over total volume, over total volume. First of all, this is 0.060 liters because of what? Because of 30 and 30 gives you 60. But the number of moles is you are using only 60, where number of moles is given by volume in liters times molarity. We're using 30 ml, which is 0.030 liters, and the molarity seal line what? Line the number of molarity here, molarity, where is molarity? Molarity for the base, molarity before mixing, line 40. This is line 40. So you want to see for line 42, molarity of the conjugate base is given by the number of moles over the total volume, where the number of moles is right there. That's the number of moles using that. So that for line what, once you have line 42 and line 43, this one for the 3, you have to read measure for the 3 here. pH this one is measured using pH or pH meter. pH meter. And then calculated 44. You see here 44 use Anderson-Alsenberg equation. 44 pH equals to pKa plus log of the base over concentration of the acid, which is line 42, 42, 43. The base is 42 here. This is line 42. This is line 41, line 41. So here 41, 42, this is the acid, this is the base. You'll plug in the numerical values for each one of them to do the pH or calculate the pH. of a power solution using Anderson-Hasselbalch equation. The rest, you now read the instruction. I've covered most of the calculation, which I believe you had to, I believe some of you had difficulty in wrapping around your mind so that you proceed with the calculation. Part 3, which is testing of the power capacity, you do not have, I don't think you will face any challenge, all right? This number 45 is just the value from the pH meter. Once you mix what is the pH, change in pH 47, all right, here, 45, real quick, maybe 45, I don't think it's hard. This is from pH. Before addition, what is the pH? After addition, what is the pH? So that our pH change is 45 minus 46. You'll have to find the absolute value. Testing the pH power. 49, 48 minus 45 give you 49. What is the pH change? Now, here, this is the volume, all right? Volume of power used in liters. You're just gonna read the instruction on how to fill each one of them for volume. Instruction state how many ml of each one of them. Real quick, I believe I have that volume. Let's see the volume of acid chain. All right. For acid number 25, this is 50. You use 25 ml, you just change the volume. Calculate the power capacity. I just want to highlight the equation you will need for that. I think there is an equation for calculating the power capacity. Let's see, right here. This is the equation, number of moles of acid used, a number of moles of hydroxide added. How do you get the number of moles? Please remember how many ml did you use before you see or you notice the change in pH. Number of moles, all right? Number of moles is given by molarity times volume in liters times volume in liters. And then the equation, this change in pH, make it absolute value. That means make it positive, whichever is small. Let's say if I find the difference between the pH after addition and before addition, and then what, you see this? It can be negative, it can be positive. Make it positive. This means absolute value. And then volume of the power, all right? Volume of the power used, you need to look at the procedure, state how many. And please use M1V1 to calculate what number of moles is given by molarity that I gave you here. All right, molarity times volume in liters. The rest should be pretty straightforward. If you have any question, you can email me. Hopefully, You won't find any problem. This data sheet is due next week, just like usual. You should upload the data sheet in its respective folder on Canvas. Other than that, thank you.